Modulation. We often hear this word when speaking about communication systems. It is a simple concept often overlooked or misunderstood but very important to understand since it forms the base for wireless communication. And it is the process of charging the signal's parameter at the carrier signal in accordance with a separate signal called the modulated signal. In this video, we will see what is modulation, its types, and importance of modulation. Let's get started. Generally, when we describe the signal, we talk about its three important characteristics: frequency, amplitude, and phase. Modulation is a simple process in which a carrier signal of a constant phase is where the phase at any given moment, frequency, the number of cycles wave per second, amplitude, the height of the wave. And let's take a look at the three types of modulation. Frequency modulation. Type of modulation, frequency of the carrier signal be altered with respect to modulated signal. As a result, we will obtain modified frequency signal in output. Next, amplitude modulation. Here, amplitude of carrier signal will be altered with respect to modulating signal and we will get the amplitude modified signal as a output. And lastly, phase modulation. Phase of the carrier signal will be amplified in this method and we will obtain phase modified signal in the output. Apart from this, there are many other modulation techniques like DSB, SSB, VSB, QAM, ASK, and much more. Let's take a look at the three main advantages of modulation. Number 1. To transmit a signal to long distances. Low frequency signals like audio or any other signals are incapable of propagating to long distances on their own. When modulating them with high frequency carrier signal, the modulated output will obtain high frequency characteristic and as a result, it can propagate longer and in turn provides more range to the user. Can be simply explained using famous stone and paper analogy. Imagine a paper as your audio signal, and when you throw it, will not go any further distance since it lacks the weight. Now wrap the paper around the stone, which represents your carrier signal. When you throw the stone, wrap paper, now it will go much further due to stone. Modulation was the same way as paper and stone, where the high frequency carrier signal provides the ability to reach the larger distance for audio signal. Number 2. To reduce the size of antenna. Antennas are used to propagate the thickness into atmosphere. Consider an unmodulated on your signal of frequency 20 kHz. The antenna height for propagating this signal would be of 3.75 kilometers and it's totally impossible to build such antenna. However, if you modulate them to 1 MHz, then you need an antenna of 7.5 meters and that is totally possible. Number 3. Avoid mixing of signals. We all know that frequency of audio signal ranges from 30 Hz to 20 kHz. So if two devices send out unmodulated audio signal, it will result in a mixing and eventually the receiver will receive some gibberish audio which will be of no use. When modulator signal from device 1 and device 2 will propagate in individual results amps and therefore preventing the audio signal for mixing. Modem and how does it work? The name modem is the abbreviation of the term modulator and demodulator. As the name implies, both functions are included in the modem. A modem is used to convert digital signals into analog signals capable of being transmitted over telephone lines, and at the receiving end of the system, modem is used to demodulate the analog signals and reconstruct the equivalent digital output. Modem are placed at both ends at the communication circuit as shown in the visual.